Hi everyone, welcome to PrepFusion. So this will be our lecture 0. In this video, we are going to study about complex number. So it might happen that you have already good idea about complex number. You would have studied it in your 11th, 12th class, or if you are a dropper, then also you might be having a good idea about complex number. So if you are someone who is comfortable with this particular topic, then you can quickly visit this topic, like within 3 to 4 minutes, you can complete the whole video. If you are someone who did not study it in a good manner in class 11th, 12th, or you are not comfortable with this particular topic, here only basics complex number we are going to see, which we have already studied in class 11th and 12th. But if you are someone from diploma or you don't have good idea about these particular numbers, then you can wait and see the whole video. Okay, so let's start. So there are two kind of number, real number and complex number. Real number we are studying from class first or second, right? Very basic real number we have already studied, like real number like 2 is a real number, or 1 is a real number, minus 2 is a real number, minus 2 by 3 is a real number, or under root 2 is a real number, pi is also a real number, or you can say minus under root 5 is also a real number. So how do you represent a real number? You represent a real number on number line, right? So this used to be our number line. So this number line goes from minus infinity to plus infinity, and 0 comes right in between. Minus infinity to plus infinity, 0 comes right in between. The right hand side is of positive numbers, like this would be 1, this would be 2, this would be 3. In that manner it will keep on going. What about the left hand side? That would be the negative number, minus 1, minus 2, minus 3, and it will keep on going like this. Now I need to represent 2. So how will I represent? 2 will be represented here. So this is your 2. This is your 2. I need to represent 1. This is my 1. I need to represent minus 2. This is my minus 2. I need to represent minus 2 by 3. Minus 2 by 3. Minus 2 by 3 is minus 0.067. Minus 0.67. Sorry. Minus 2 by 3 is minus 0.67. So that would be between minus 1 to 0. So here, somewhere here it would be minus 0.67. Right? What about under root 2? Under root 2 is 1.414. So that would be just above 1. Somewhere here. Pi is 3.14. So that would be somewhere here. In the same manner, you can represent under root 5 as well. That would be some minus under root 5. That would be somewhat minus under root 5. What would be the value? It would be roughly around minus 2 point something. So that would be somewhere here. So in that manner, you can represent your complex number on one line only. Sorry, not complex number. You can represent your real numbers on this one line only. Right? So these were our real numbers which were represented in 1D, in one dimensions. So these real numbers were represented in one dimension. But if you talk about complex number, so complex numbers have two part, real part and imaginary part. So how do you represent a complex number? The complex number is somewhat like this, 2 plus 3j. So this part is known as real part and this part is known as imaginary part. Look, this is a real number, 2 is a real number, yes. 3 is a real number, yes. But where there is this j is making it a imaginary number. Look, 3 is a real number, right? But 3j is an imaginary number. This is an imaginary number. Okay? 3 is a real number, 3j is an imaginary number. So real part plus imaginary part will make the complex number. Let's take more examples. The number could have been minus under root 3 plus pi j. This is also a real number, this is also a real number, but since j is connected, so this becomes imaginary part. So this is the real part, this is the imaginary part. Now how do you represent that? It is having two parts, so you need two dimensions, you need 2D. So I will make a 2D coordinate, 1D and 2D. So I need to make 2D coordinate. Similarly, the middle point, this would be 0 only. The right hand side would be 1, 2, 3 in that manner going till infinity. The left hand side would be minus 1, minus 2, minus 3 going till minus infinity. Now what about the upper side? So upper side would be positive, 1, 2 in that manner going till infinity. What about the downward side? Downward side would be negative, minus 1, minus 2 going till minus infinity. So on this particular axis is known as real axis. I will call this axis as x axis, and this axis I am calling as y axis. X axis, y axis. So this axis is known as real axis. So here you will represent the real numbers. Okay, this is known as real axis, and the y axis is known as imaginary axis. So here you will represent the imaginary number. What do I mean by that? Let's represent 2 plus 3j. So 2 on real axis, and 3 on imaginary axis. 2 plus 3j I need to represent, 2 plus 3j. So 2 on real axis and 3 on imaginary axis. So 2 on real axis and 3 on imaginary axis. Where I will go? 3 is somewhere here. So this is how I will represent 2 plus 3j. So this is my imaginary axis. So 2 on real axis and 3 on imaginary axis. So the number would be somewhere here. 2 here and 3 here. Right? So the number would be somewhere here. So this would be your 2 plus 3j. This is how I will represent the number. Because here there are two parts, real part and imaginary part. That's why I need two dimensions. I need 2D coordinates. But here I required only one coordinate. How will I represent minus 3 plus pi j? Minus 3 plus pi j. Minus 3. Real part minus 3. Plus pi. Pi is 3.14. So minus 3 plus 3.14. That would be somewhere here. Because this is 3. So 3.14 would be somewhere here. So this would have been your minus 3 plus pi j. Or j pi you can say. Usually we denote j first and later on the number. Okay. So here also I should have written j3, and here also I should have written j pi. Usually we write j first and then the number. So minus 3 plus pi j. In the same manner you represent 2 minus 3j. So where would be 2? 0, 1, 2. 2 would be somewhere here. This would be your 2. And where would be minus 3? Minus 3 would have been minus 1, minus 2 and minus 3. Minus 3 would have been somewhere here. So 2 here and minus 3 here. So this would have been your Z2. This number would have been your Z2. Let's remove all this part. So 2 minus 3. So this would have been your Z2. Right? What about minus 2 plus 3j? So this is 0. Minus 1, minus 2 plus 3j. 1, 2 and 3. That would have been somewhere here. Minus 2 plus 3j. Minus 1, minus 2 plus 1, 2, 3. So minus 2 plus 3j, because this is the positive part, this is the negative part. So this is the real axis and this is the imaginary axis. This is the real axis, this is the imaginary axis. Real axis and imaginary axis. Well and good. So this would have been your Z3. What about Z4? Minus 2 minus 3j. So this is your 0. Where would be minus 2? Minus 1, minus 2. This would have been your minus 2. And where would be minus 3? Minus 3 would be coming downward. Minus 1, minus 2 and minus 3. So this would have been your minus 3. So minus 2 minus 3j. So this would have been your minus 2 and this would have been your minus 3. So minus 2 and then coming down minus 3. So this would have been your Z4. So this would have been your Z2, Z3, Z4. Here you see 2, 3, 2, 3, 2, 3. But because of the sign, they are represented different. Minus 2 minus 3j. So you need to see, okay, minus 1 minus 2 is here. Minus 3 would be downward. So this would be Z4. Here minus 2 plus 3j. So minus 2 plus 3j, that would be Z3. 2 minus 3j, 2 minus 3j, that would be Z2. And if I call this as 2 plus 3j, 2 plus 3j. So 2 plus 3j, that would have been your Z1. If I call this as Z1. So 2 plus 3j. Well and good. Okay. Now we will talk about the magnitude of complex number. So complex number has two parts. This will be having two parts, magnitude and angle. Magnitude and angle. It has two parts, magnitude and angle. So first we are going to study about magnitude. So what would be the magnitude of a complex number? Let's just say real number. I am talking about real number. Real number is minus 2. Okay, real number is 2. So what is the magnitude of this number? That is 2 only. Magnitude of this number is 2. Now if the real number is, let's just say minus 5. So what is the magnitude of minus 5? That is 5. So magnitude is always a positive number. Magnitude is always a positive number. So you need to tell the magnitude of a complex number. That means the magnitude of complex number would have been a plus a square. You take this number, do the square, plus you take this number, do the square, and then you take the under root. So under root a square plus b square, that would be the magnitude of a complex number. Are you getting this point? So find the magnitude of this complex number 2 plus 4j. What you need to do? Take the under root, take the square of this 2 square plus take the square of 4 square. That would have been 4 plus 16. That would have been under root 20. Okay, well and good. What about the magnitude of this number? Take the under root. Just a second. This is moving. So take the under root. Then square of under root 3 square plus 2 square. Square of minus under root 3. But square of any number would be positive number only, no? What I am saying, square of minus 2, that would have been 4, and square of 2, that would have been also 4. So you don't need to think about minus sign here. So minus 3 and minus under root 3 whole square plus 2 whole square, and then take the under root. So what would be the square of minus under root 3? That would be 3 plus 4. So magnitude will be under root 7. What about this one? Do I need to care about negative sign? No, because I know that square of negative sign would be positive only. So what I will do? First I will take the under root. In the under root I will do the square of minus 3 plus I will do the square of minus under root 3. So that would have been under root 9 plus 3. Under root 9 plus 3. So that would have been under root 12. What about this one? Under root 2 square plus under root minus 5 square. So that would have been 4 plus 5. That would have been under root 9. Now what would be the answer here? Plus minus 3. What is the answer of under root 9? Is it plus minus 3? No, it is plus 3 only. The answer of under root 9 is never plus minus 3. Answer of under root 9 is plus 3 only. If it has written like this, plus minus under root 9, then you would say the answer is plus minus 3. This value will always give you a positive number. This particular value will always give you a positive number. So let's just say x square is equals to 9 is written. So what is the value of x? You would say it is plus minus 3. Yeah, that is correct. So how would I solve it? That I will take the under root on both of the side. If I take the under root on both of the side, what will happen? X would be equals to plus minus under root 9. And then you will solve this under root 9. Under root 9 will always give you 3. So answer would have been plus minus 3. So when you removed the square, at that time plus minus came. Not after solving the under root 9. Under root 9 is always 3. Under root 9 is always 3. But if it was written x square is equals to 9, when you removed that square, at that time, when you were taking the under root, at that time plus minus came. So value of under root 9 is always 3. It is not plus minus 3. Okay? Plus minus under root 9 will give you plus minus 3. Are you getting this point? So here what we are having? Are we having the plus minus sign here? No. What did I tell you? The magnitude of z is under root a square plus b square. There is no plus minus. Right? So here under root a square plus b square. So under root 9 we are getting. So under root 9 will give you plus 3 only. Not plus minus 3. Are you getting this point? The result of under root is always a positive number. Well and good. So this was just simple mathematics that I was teaching. So yeah, so Z4 is 3. So you would have understood the magnitude of a complex number. Is that clear? Okay, let's move to the next part. Concept of angle. So now we are going to study about angle. So there is this particular line. I am asking you, let's just say this was a complex number Z1. This was a complex number Z1. Z1 was 2 plus 3j. So 2 plus 3j, this is a complex number Z1. It could be any random complex number. Now it is making an angle of 30 degree. So if I ask you how much angle this Z1 is making, so someone will say that sir it is making 30 degree. But someone like me can say that sir it is making an angle of 150 degree. The other guy will say that sir it is making an angle of, how it is 150? Because complete would be 180. So 180 minus 30 it would be 150. Right? Someone will say that sir 90 plus 30 it is making 120 degree angle. So different guys can say different answer. So there has to be something common, no? Like if you are saying it is making an angle of 30 degree, then angle of 30 degree with respect to what? If I ask you how much angle Z1 is making, someone will say, sir, 30 degrees, someone will say 150 degree, someone can say, sir, this much angle it is making. So this much angle would have been 180 plus 30. So that would have been 210. So different people can say different numbers. So for that we need to make a common ground that yes, with respect to a particular thing, the angle will be defined. So angle will always be defined with respect to positive x-axis, okay, in anti-clockwise direction. What do I mean by that? What is the meaning of anti-clockwise? So this is your clock, right? This is your clock. So clock always goes like this. The time always runs like this, right? So this is known as clockwise. And what will be anti-clockwise? This will be anti-clockwise. Okay. So this is known as clockwise and this is known as anti-clockwise. So angle is always defined with respect to positive x-axis in anti-clockwise direction. What do I mean by that? This is your x-axis. This is the positive part and this is the negative part. So angle is always defined with respect to positive x-axis, with respect to this positive part in anti-clockwise direction. In anti-clockwise direction. So from the positive x-axis in anti-clockwise direction, how much angle you need to walk to reach to this line? What I am saying, from the positive x-axis, how much angle you need to walk in anti-clockwise direction to reach to this line? That is 30 degree. So angle made by Z1 would be 30 degree. What I am saying, again I will repeat. From the positive x-axis in anti-clockwise direction, how much angle you need to walk such that you reach till this line? That is 30 degree. So angle made by Z1 would have been 30 degree. Say yes or no. Okay. Now this is not the only way of representing the angle. The other way could be, from the positive axis in clockwise direction, how much I am walking such that I reach till this particular line. From the positive x-axis, from positive x-axis in clockwise direction, how much I am walking such that I reach this particular line. So how much I am walking? 360 minus 30 degree, because this complete angle would have been 360. So 360 minus 30. So how much I am walking? 330 degree. But if you are taking the angle in clockwise direction, then you need to take a negative sign. So there are two ways of representing a particular number. Either you can work in anti-clockwise direction or you can work in clockwise direction with positive x-axis. If you are working in anti-clockwise direction, that means the angle would be positive. And if you are working in clockwise direction, then the angle would be negative. So from the positive x-axis, how much angle you need to work to reach to this particular line? So I need to work 30 degree. So my angle is 30 degree. What could be the other way? From the positive x-axis, how much angle you need to work to reach to this particular line? That is 330 degree. But if I am working in clockwise direction, then the angle would be negative. So 330 degree I need to work, but in the anti-clockwise direction, that's why the negative sign would be there. So there are two possible ways of representing, 30 or minus 330. Okay, 30 or minus 330. If I ask you, this is a number Z2. This is a complex number Z2. So how much angle Z2 is making? Will you say 40 degree? Absolutely not. It is not making 40 degree angle. Here I have shown 40 degree. That doesn't mean it is making 40 degree angle. What I would say, from the positive x-axis, how much I need to walk to reach to this particular line? From the positive x-axis, how much I need to walk in the anti-clockwise direction to reach to this particular line? So how much angle I need to walk? This complete was 180. So this would have been 180 minus 40 degree. So 140 degree. So angle made by Z2 would have been 140 degree. If I know this angle, then I know this angle as well. So angle made by Z2 would have been 140 degree. Or what I can say, from the positive x-axis in anti-clockwise direction, how much I need to walk to reach to this particular, from positive x-axis in anti-clockwise direction, from the positive x-axis in clockwise direction, how much I need to walk to reach to this particular line. So how much is this angle? This is 180. This much is 180 plus 40. Are you getting this point? This much is 180 plus 40. So what would have been 180 plus 40? That would have been 220. But if I am working in clockwise direction, the angle would be negative. So answer would be minus 220 degree. Are you getting this point? One more thing, if I know this 140 degree, I can tell this minus 220 without even the diagram, because I know that 140 degree plus the negative angle would be equals to, or you can say basically 140 degree plus the other angle would be equals to 360 degree. So the other angle is coming out to be 220, but I need to take a negative sign here. Here also one angle, that is 30 degree, plus the other angle would be equals to 360. What is the answer we are getting? 330. But I need to take the negative sign as well. Okay. So you just need to subtract this angle. You just need to subtract 360 from this angle. What you are getting? Minus 330. You just need to subtract 360 from this angle. What you are getting? Minus 220 degree. So that would be the other angle. Or you can show by the diagram as well. Okay. I hope you are understanding the concept of angle. Angle is always measured from positive x-axis in the anti-clockwise direction. But if you are working in clockwise direction, you just need to take a negative sign. Okay. So two ways of representing the angle. Let's try out this particular angle. Will you say the angle made by Z3 is 35 degree? Absolutely not. The angle made by Z3 is 35 degree? No. The angle made by Z3 will be defined with positive x-axis. So I need to work from positive x-axis in the anti-clockwise direction. From positive x-axis in the anti-clockwise direction. So how much did I work? 180 degree. 180 degree will be this much plus 35. 180 degree plus 35. So what that would be? 215. So my angle would have been 215. What would be the other angle? 215 minus 360. 215 minus 360. That would have been the other angle, right? So that would be 145 degree. So that would be 145 degree. But negative sign. Or what I would have done, that from the positive x-axis in the clockwise direction, how much I need to work? From the positive x-axis in clockwise direction, how much I need to work to reach to this particular line? So that would be, this total would be 180. So 180 minus 35. 180 minus 35. What that would be? 145. But if I am working in the clockwise direction, then negative sign would be used. So usually how do we represent? Usually we represent by the smaller number. 30 degree is smaller or 330 degree is smaller? 30 degree is smaller. So I will represent by 30 degree. Although both are correct, but usually I will represent by 30 degree. 140 or 220? 140. 215 or 145? 145. Okay. Usually I represent by smaller number, but both of them are correct. 215 is also correct, minus 145 is also correct, but usually we will represent by the smaller number. Okay. What about this angle? The angle made by Z4 is 50 degree. Is that correct? Absolutely not. So what I need to do? I will say that I will work from the positive x-axis in the anti-clockwise direction to reach to this particular line. So how much I need to work? What do you think? So complete rotation would have been 360. So 360 minus 50, that would have been 310 degree. So one, I can say that the angle is 310. Or what I would say? That from positive x-axis, I need to work in the clockwise direction to reach to this particular line. From positive x-axis, I need to work in the clockwise direction to reach to this particular line. So how much do I need to work? 50 degree. But if I need to work in the clockwise direction, then I need to take a negative sign as well. So I will represent by minus 50 because minus 50 is the smaller number. So one which is the smaller number, by that we will represent. Okay. In the clockwise direction, how much I need to work to reach this particular line from positive x-axis. So angle is always defined with respect to positive x-axis. In clockwise direction you can say, or in anti-clockwise direction you can say. If you go in anti-clockwise direction, then the angle would be positive. If you go in clockwise direction, the angle would be negative. Everything is crystal clear. So this is the concept of angle. This is not with respect to a complex number. This is general way. In general way, if someone is asking you the angle, then this is how you will define it. Whether it is for complex number or it is for anything else. In general way, the angle is defined like this. Positive x-axis, anti-clockwise direction, positive x-axis, clockwise direction. All clear? Let's study about tangent. This you might be already knowing. What is the meaning of tangent, right? So tan theta, how tan theta will be defined for this particular diagram? How tan theta will be defined? So that is equals to perpendicular divided by base. Perpendicular by base. I hope you know this thing. Basic trigonometry in class 10th we have studied. Perpendicular by base. So this is the tan theta. So from here if I need to write down theta, that would have been tan inverse perpendicular by base. Can you let me know the value of theta for this particular diagram? I need the value of theta for this particular diagram. So what do you think, what will be your answer? So your theta is equals to, if I call this angle as theta 1, is it fine for you? I am calling this angle as theta 1. So can I say my theta is equals to 180 degree plus theta 1? Say yes or no. Because this much angle is 180 degree. Then you worked more by theta 1 and you are working in the anti-clockwise direction. From here, from positive x-axis, I am working in the anti-clockwise direction. So anti-clockwise I worked 180 degree. Then I worked for more theta 1 as well. So 180 degree plus theta 1. Can I find the value of theta 1? Yes. What would be my tan theta 1? So my tan theta 1 would be equals to perpendicular by base. Perpendicular by base. So theta 1 would have been equals to tan inverse perpendicular by base. So what would be the value of theta? Theta would be 180 degree plus tan inverse perpendicular by base. So that would have been your theta. Here I am talking about the magnitude, okay? This P is the magnitude, B is the magnitude. Basically, this P will be a negative number, na? Right? Because you are working here. So P will be a negative number and B will also be a negative number. But here I am talking about, I am not talking about the negativity here. That negative is ignored. Let's just say this was minus 2 and this was minus 3. So I am talking about 2 by 3, not minus 2 by minus 3. Here I will write 2 by 3. Are you getting this point? We will see the example, it will be more clear to you. So let's see the example. Find the angle made by following complex number. The first number is 3 plus 4j. So first I will represent 3 plus 4j. So where will be my 3 plus 4j? So on real axis I need to work for 3. On imaginary axis I need to work for 4. So the number would be somewhere here. So 3 plus 4j. This would be my number. 3 plus 4j. Angle I need to find. What I need to find? Angle. So angle I always measure from positive x-axis in the anti-clockwise direction. So this angle I need to find. Right? So just a second. I will make it a bit smaller. So from positive x-axis in the anti-clockwise direction. So this angle theta I need to find. Can you let me know the height of this particular thing? That is 4. And how much is this? This is 3. The height is 4, this is 3. So what will be my tan theta? Tan theta would be equals to 4 by 3. So what will be your theta? Tan inverse 4 by 3. Which is equals to, you can do it in the calculator, it is equals to 53 degree roughly. Okay. So theta is 53 degree. So angle made by this complex number is 53 degree. I just represented the number, then I worked in the anti-clockwise direction from positive x-axis. So how much I need to work? 53 degree I need to work. How did I find it? 3 plus 4j. So 3, 4j. So 4 by 3. Tan inverse 4 by 3. That would be 53 degree. Let's talk about the second number. Minus 3 plus 4j. So minus 3 would have been somewhere here. Minus 3 plus 4j. 4 would have been somewhere here. So this would be my complex number. This would be my complex number. Minus 3 plus 4j. Can you let me know this particular height? This particular height. What will be this height? This height will be 4, right? Minus 3 plus 4j. So this height will be 4. And what will be this distance? This distance would be 3. What I need to find? I need to find the angle. So how do I define the angle? From positive x-axis. From positive x-axis, how much I need to work? So this angle I need to find, theta. So what do you think, what will be your theta? I am representing a number theta 1. Sorry, I am representing an angle theta 1. Can I find this theta 1? Forget about anti-clockwise, clockwise. Can you find this theta 1? Yes, this theta 1 would be equals to tan inverse 4 by 3. Because your tan theta 1 tan theta 1 is equals to perpendicular upon base. I am only talking about the magnitude. If I make this diagram and I ask you the theta, so 4 by 3. Forget about the magnitude, that sir this is negative, this is positive. Only I am talking about the distance. This distance is 3 and this distance is 4. So what will be my tan theta 1? That would be 4 by 3. From here you can say that my theta 1 is tan inverse 4 by 3. So this angle is tan inverse 4 by 3. What I need to find? I need to find theta. So what is theta? What do you think? 180 degree minus theta 1. Because I know that theta plus theta 1 is equals to 180 degree. So what would be my theta? That would be 180 degree minus theta 1. So your answer would be, your theta would have been 180 degree minus tan inverse 4 by 3. What is tan inverse 4 by 3? That is 53 degree. So 180 degree minus 53 degree. That would be equals to 127 degree. So here this guy is making 127 degree. So Z2 is making, this was your Z2, this was your Z1. So Z2 is making 127 degree angle. Here Z1 was making 53 degree angle. Are you getting the point that how we are calculating the angle? Usually people remember the formula for this one, that if it is in second quadrant then this formula I will apply, if it is in third quadrant then this formula I will apply. But no, nothing, no formula. We need to see the pure concept. What does the concept says? You draw your Z2. Where is Z2? Here is my Z2. Now what I need to find? I need to find the angle. Angle is always defined with respect to positive x-axis in the anti-clockwise direction. So this angle is theta. Now can I find the value of theta 1? Why I am finding the value of theta 1? Because I know that theta 1 plus theta would be 180 degree. And I am talking about theta here. So theta plus theta 1 is equals to 180 degree, that I know. If I am able to find the theta 1 is equals to 53 degree because it is tan inverse 4 by 3. So theta 1 is equals to 53 degree. So what will be my theta? 180 minus 53. That would be 127. You try doing this on your own. Minus 3 minus 4j. So where would be minus 3? Minus 3 would be somewhere here. Where would be minus 4? Minus 4 would be somewhere here. Minus 3 minus 4j. So minus 3 minus 4j. So this would be your Z3. This would be your Z3. So your Z3 would be somewhat like this. This would be your Z3. Now what I need to do? I need to find the angle. So for finding the angle, what do? I always work in the anti-clockwise direction from positive x-axis. So this much angle I need to find. Can I find this much angle? If I call this as theta 1. What would be your theta 1? What do you think? Can you find theta 1? What will be your theta 1? What do you think? What is this height? Or you can say what is this perpendicular? This height is 4, right? So this same height is here. So this height is 4. So this height is 4. And what about this length? This length is 3. This length is 3, this height is 4. So what would be your theta 1? Theta 1 would be equals to tan inverse 4 by 3. That is equals to 53 degree. अरे यार ये बहुत मूव कर रहा है आज. So theta 1 is equals to 53 degree, right? This angle is 53 degree. But what I need to find? I need to find this theta. This theta is the angle made from positive x-axis. So that would have been, theta would have been 180 degree plus theta 1. Say yes or no? 180 degree plus theta 1. So 180 degree plus 53 degree. That would have been the answer. What we are getting? 180 plus 53, that would be 233 degree. Right? Yeah. But I will not represent by 233 degree. Why is that so? Because I told you I will represent by the smaller number. So what I will do? From the positive x-axis, I need to work in the clockwise direction. From the positive x-axis, I need to work in the clockwise direction. Can I find this angle? Yes. Theta 1 is 53 degree. So what would be this angle? This angle would have been 180 minus 53. 180 minus 53. 180 minus 53. What I am doing? Now I am writing down the angle in the clockwise direction. So from the positive x-axis, I am working in the clockwise direction. So how much I need to work? 180 minus this angle, that is 53. So 180 minus 53, what that would be? 127. But that would be negative. Why that is negative? because you are working in the clockwise direction. So that would have been minus 127 degree. So I will represent by minus 127. I will not represent by plus 233 degree, although this is also correct, but the better way of representing would be minus 127 degree. Okay, always the smaller number. So I will walk in the clockwise direction. I will walk in the clockwise direction from positive x-axis. So how much I need to walk? This much angle I need to walk. I already know my theta 1, that is 53 degree. So what would be this angle? This angle would have been 180 minus 53, that is 127. But since I am walking in the clockwise direction, so negative sign will be used. Everything is crystal clear. We have built up the concept from zero. I am not asking you to remember a single formula. Only you just need to know the concept of tangent. Then you will be able to write down the angle very easily. Well and good. Let's talk about the other one. Plus 3 minus 4j. So where will be plus 3? Plus 3. Minus 4j would be somewhere here. So plus 3 minus 4j. So the number would be somewhere here. This would be your Z4. This would be your Z4. Minus 3 plus 4j. Sorry, 3 minus 4j, not minus 3 plus 4j. 3 minus 4j. So this would be your Z4. What I need to find? I need to find the angle made by Z4. So I need to walk from positive x-axis in the anti-clockwise direction. But will I do this thing? No. I will do this thing, that I will walk from positive x-axis in the clockwise direction. And the angle now I will write, that would be negative. The angle that I am gonna write, that would be negative. So can I find this angle? My target is to find this particular angle. So can I find this angle? Yes, I can find. How much is this length? This length is 4. And how much is this length? This length is 3. So if I need to write down the theta, if this is my theta, so my theta would be, since I am working in the clockwise direction, already a negative sign would be there. Tan inverse 4 by 3. 4 by 3. And that is minus 53 degree. So Z1 was making 53 degree angle, Z2 was making 127 degree angle, Z3 was making minus 127 degree angle, and Z4 was making minus 53 degree angle. Did you understand the point, that how we are finding the angle? No formula, nothing. Z1 53 degree, Z2 in the second quadrant it is. So this angle I can already find. I need to take the angle in the anti-clockwise direction. So that would have been 180 minus 53, 127 degree. What about Z3? Z3 is in third quadrant. Okay, this is known as first quadrant, this is known as first quadrant, this is known as second quadrant, this is known as third quadrant, and this is known as fourth quadrant. Okay, if you don't know, 1 2 3 4. So Z3 is in the third quadrant. Now I can take the angle in the clockwise direction as well, I can take the angle in the anti-clockwise direction as well. I know that the clockwise direction angle would be lesser, anti-clockwise direction would be more angle. So I will take the angle in the clockwise direction. If I am going in the clockwise direction, that means the angle would be negative. Can I find this angle? Yes. This is the height 4, this is the base 3, 4 by 3. That would be 53 degree. So this angle I already know, that is 53 degree. So how much will be this angle? 180 minus 53. So that would be 127. But if you are working in the clockwise direction, negative sign would be there. So minus 127. Here I can go by this as well. But why would I go like this? I would go clockwise direction. So can I find this angle? Yes, that would be 4 by 3. The angle would have been 53 degree. But if I am working in the clockwise direction, I need to take a negative sign. So minus 53 degree. So this is how you need to tell. Is that clear to you or not? So in any quadrant, anywhere your complex number would be there, you will just draw the diagram and think. Don't apply any formula. If you remember, if you mug up the formula, then there is very high chance that you will be getting it wrong in the examination hall. And it will be used everywhere, whether you study EMFT or you study signal systems or you study network analysis. Everywhere these kind of concepts will be used. So I hope you are comfortable with these kind of concepts now. Well and good. How do we represent a complex number? So a complex number is represented by its magnitude and angle. Where I told you this? Magnitude and angle. Did we learn how to find out the magnitude? Yes. Did we learn how to find out the angle? Did we learn how to find out the angle? Where did that go? Yeah. Did we learn how to find out the angle? Yes. So can we represent the complex number? Yes. So how will I represent? What will be the magnitude? Magnitude would be, how will I represent? Magnitude and angle. So magnitude and angle I will represent like this. I will make the sign of angle and this is how I will represent. Or you can represent magnitude e to the power j angle. This is how you can represent. Are you getting this point? Magnitude, and then you show this sign of angle and you write down the angle here, or you can represent magnitude and then e to the power j angle. So you try finding the angle, you try finding the magnitude as well, and then you represent all these numbers. It's your task, do it on your own. I will take a break, I will drink some water, and then I will come back and show you the solution. Okay, so do it on your own first. Yeah, so did you try this one on your own? So Z1 was 3 plus 4j. So can you let me know the magnitude of Z1? That would have been under root 3 square plus 4 square. That would be under root 9 plus 16. That would be under root 25, and that would be 5. So magnitude of Z1 is 5. What would be the angle? Angle we have already found, 53 degree. Angle we will always find by the diagram. So angle is 53 degree. So angle I already know. This is the magnitude, and if I write down the angle of Z1, that would be 53 degree. So how will I represent Z1? Z1 will be represented as magnitude and the angle, or you can write down magnitude e to the power j 53 degree. How we are representing e to the power j 53 degree, that we will see. But as of now, you just need to see the angle is 5 e to the power j 53 degree. Okay, I will add a page. Let's talk about Z2 now. So what was your Z2? Z2 was minus 3 plus 4j. Minus 3 plus 4j. यार ये फिर बहुत मूव कर रहा है. This writing pad moves too much. Minus 3 plus 4j. So what is the angle of Z2? Angle of Z2 is under root minus 3 whole square plus 4 square. So that would be 9 plus 16 under root 25. That would be equals to 5. So mode of Z2 is 5. What about the angle? Have we find out the angle? Minus 3 plus 4j. Minus 3 plus 4j. So the angle was 127 degree. Minus 3 plus 4j. So the angle was 127 degree. Right? So what would be your Z2? So Z2 can be represented as magnitude will be 5 only. Angle is 127 degree. Or you can represent 5 e to the power j 127 degree. This was your B. What about C? Z3. So now you should be able to do on your own. Z3 minus 3 minus 4j. Minus 3 minus 4j. So can you let me know the magnitude of minus 3 minus 4j? Yes. That would be minus 3 whole square plus under root minus 3 whole square plus minus 4 whole square. So that would be 9 plus 16. That would be under root 25 only. And that would be equals to 5. And what about the angle? Angle have we find out? Minus 3 minus 4j. Minus 3 minus 4j. So angle was minus 127. So angle was minus 127 degree. So Z3 is magnitude is 5 and the angle is minus 127 degree. Magnitude is 5 and the angle is minus 127 degree. So 5 e to the power minus j 127 degree. What about D? Z4. So Z4 is 3 minus 4j. 3 minus 4j. So what is the magnitude of Z4? That is under root 3 square plus minus 4 square. 9 plus 16, that would be under root 25, and that would be equals to 5. And what about the angle? Angle would be minus 53 degree, right? So how will I represent my Z4? Z4 is 5, angle is minus 53 degree, or you can say your Z4 is 5 e to the power minus j 53 degree. So this is how you represent all the numbers. This was your Z3, this was your Z2, this was your Z4. Magnitude and the angle, magnitude and the angle. Here also magnitude and the angle. Well and good. Okay. So what is this e to the power j theta? Here some magnitude was there, that I am representing by a. E to the power j theta, e to the power j theta. So what is this? A e to the power j theta. So here magnitude is a. What is the meaning of e to the power j theta? That is cos theta plus j sin theta. Are you understanding? E to the power j theta can be represented as cos theta plus j sin theta. E to the power j theta is equals to cos theta plus j sin theta. You can open it up like this: a cos theta plus j a sin theta. This is how you can open it up. So I need to represent 5 e to the power minus j 53 degree in this manner. So what I will do? 5 remains as it is. Cos, what is the angle? Minus 53 plus j sin, what is the angle? Minus 53 degree. Now if you know trigonometry, then you would know that cos of minus theta is equals to cos theta and sin of minus theta is equals to minus sin theta. Do you agree to this point? Sin of minus theta, it comes outward, minus sin theta, cos of minus theta is equals to cos theta. All good? 5. What will be the value of cos 53? So you can calculate in your calculator, the value will be 3 by 5. Okay. Now this negative sign will come outward, so plus j would become minus j. What will be the value of sin 53? So you can calculate in your calculator, it would be 4 by 5. So what you are getting? 5, and this 5 will be going inside. So 5 into 3 by 5, that would be 3 minus j. 5 into 4 by 5, that would be 4. So 3 minus 4j you are getting. So this number can be represented by 3 minus 4j. Is that correct? Let's find out. This was the number 5 e to the power minus j 53 degree. 5 e to the power minus j 53 degree. Is that represented by 3 minus 4j? Yes, it is represented by 3 minus 4j. It is represented by 3 minus 4j. Try doing the same with this particular number. So 5 cos 127 degree plus j sin 127 degree. So if you have studied trigonometry, then you would know that cos 180 minus theta is equals to minus cos theta and sin 180 minus theta is equals to sin theta. So if I put the value of theta equals to 53 degree, if I put theta equals to 53 degree, so cos 180 degree minus 53, that is equals to minus cos 53 degree, right? And sin 180 minus 53, that would be equals to sin 53 degree. What is 180 minus 53? That is 127. So cos 127 and sin 127. So sin 127 degree is equals to sin 53 degree and cos 127 degree is equals to minus cos 53 degree. So 5 as it is. Cos 53 was 3 by 5. So minus cos 53 would be minus 3 by 5 plus j. Sin 53 was 4 by 5. Sin 53 was 4 by 5. So what you are getting? Minus 3 plus 4j. So minus 3 plus 4j can be represented by 5 e to the power j 127 degree. So where it is 5 e to the power j 127 degree minus 3 plus 4j. Yes, both are same. So if it is given this, if this is given, can you go here? Yes. And if this is given, can I come here? Yes. So from this point to this point I can go, and from this point to this point I can come. Here we are just doing the opposite process. How will you do the opposite process? This is how you will do the opposite process. Is that clear to you? These are just some basic trigonometry, nothing else. So I will just keep it here in the box. I will just keep it here in the box. So these are just basic trigonometry, nothing else. All good? All fine? Let's see the final point. We need to add two complex number, we need to subtract two complex number, we need to multiply two complex number, and we need to divide two complex number. So Z1 and Z2 are given. So first I need to do Z1 plus Z2. So Z1 3 plus 4j plus Z2. What is Z2? Z2 is minus 2 minus 3j. So always you need to remember one thing, the real part will be added with the real part and imaginary part will be added with the imaginary part. What I mean to say is that this is your 3 plus 4j minus 2 minus 3j. So what you can do? 3 minus 2, plus 4j minus 3j. What is 3 minus 2? That is 1. 4j minus 3j would be equals to j. So this is the answer. Okay. 3 minus 2 is 1. 4j minus 3j is equals to 1. So 1 plus j. Z1 plus Z2 is 1 plus j. This is first one. What about the second one? Z1 minus Z2. So what is your Z1? 3 plus 4j. Z1 is 3 plus 4j minus Z2. What is Z2? Z2 is minus 2 minus 3j. So 3 plus 4j plus 2 plus 3j. So 3 plus 2, 3 plus 2 will be 5. 4j plus 3j, that will be 7j. So this is your Z1 minus Z2. So this is the result of Z1 minus Z2. All good? Next you need to do Z1 dot Z2. So 3 plus 4j multiplied with minus 2 minus 3j. This both of them you need to multiply. So what you can do, first you multiply 3 with minus 2 minus 3j, then you multiply 4j with minus 2 minus 3j. What I mean to say is that first I will multiply 3 with minus 2 minus 3j, then I will multiply 4j with minus 2 minus 3j. So 3 is multiplied with this, what you are getting? Minus 6 minus 9j. And if you are multiplying 4j, so 4j minus 2, 4j minus 2, that would be minus 8j. 4j minus 2 would be minus 8j. Now you need to multiply 4j into minus 3j. 4j into minus 3j. So what you will be getting? Minus 12 into j square. 4j into minus 3j. 4j into minus 3j. Minus 12 into j square. Now what is j? We did not talk about this j. So j is actually under root minus 1. This j is under root minus 1. So what do you think, what will be the value of j square? J square will be minus 1 only. J is under root minus 1. So if I do the square, then under root will be 1. So j square would be minus 1. So this j square would be minus 1. So minus 12 into minus 1, what that would be? Plus 12. So here what I am going to write? Plus 12. So what you are getting? 12 minus 6, that would be 6 minus 17j. Say yes or no. Did you understand this point? I multiplied 3 plus 4j multiplied with minus 2 minus 3j. So 3 minus 2 minus 3j plus 4j minus 2 minus 3j. So minus 6 minus 9j plus minus 8j. Then there is a plus sign, 4j into minus 3j. So I should not remove this thing, that j is equals to under root minus 1. If you do the j square, that would be minus 1. What about j cube? What do you think? What will be j cube? J cube can be written as j square. J cube can be written as j square into j. Say yes or no. What is the value of j square? Minus 1. J I can write it as it is. So j cube is equals to minus j. What about j to the power 4? So j to the power 4 can be written as j square dot with j square. So what is j square? Minus 1. Multiply with again minus 1. So minus 1 is multiplied with minus 1. What you are getting? 1. So j to the power 4 is equals to 1. In that manner you can find out the values. J cube is minus j. J square is minus 1. And what is j? Under root minus 1. So what we are getting? 6 minus 17j. Right? Calculation all perfect. 12 minus 6 is 6 and this is minus 17. What about Z1 by Z2? Z1 by Z2. So D fourth one. Z1 by Z2. 3 plus 4j divided by minus 2 minus 3j. So there are multiple ways of solving, but how I will solve this particular calculation? What I will do, I will first represent it in this polar form. This is known as polar form, okay? This is known as polar form. That magnitude and the angle. So this is known as polar form. So I will represent my number Z1 in the polar form, Z2 in the polar form. So how you can represent Z1 in the polar form? Z1 in the polar form. What that would be? 3 plus 4j. 3 plus 4j. So what will be the magnitude? Under root 3 square plus under root 4 square. Under root 3 square plus 4 square. So what will be the answer? 5. And what will be the angle? 53 degree. This we have already seen. 3 plus 4j. 3 plus 4j. So 5 e to the power 53 degree. Try representing Z2 on your own. How will you represent Z2? That is minus 2 minus 3j. Minus 2 minus 3j. So what will be the magnitude? Magnitude will be minus 2 square plus minus 3 square. Minus 2 square plus minus 3 square. This would be the magnitude, and angle you need to find, that I am calling as theta. Okay, and this should be represented 5 e to the power j 53 degree. So what will be the magnitude? That is 4 plus 9 under root 13. 4 plus 9 under root 13, and the angle I need to find. So for finding the angle, what I need to do? Make the diagram. So minus 2 minus 2 minus 3, the point will be somewhere here. This is minus 3. So this would be my complex number, minus 2 minus 3. Angle I need to find. I need to work from positive x-axis. I can work anti-clockwise as well, I can work clockwise as well. So I will work clockwise because this is the smaller angle. If I am working clockwise, that means the angle would be negative. Can I find this particular angle? Yes. What will be this angle? You can see here, directly you can see. So this much length is 3, this much length is 3, and this much length is 2. If I call this angle as theta 1, so what will be my theta 1? Theta 1 would be equals to tan inverse 3 by 2, tan inverse 3 by 2, height divided by the base, tan inverse 3 by 2. So let's find out in the calculator what is tan inverse 3 by 2. Tan inverse, that is 56.30. 56.30. So what will be your theta? Theta would be, first there would be a negative sign, 180 degree minus 56.30. Why 180 degree? Because this complete will be 180 degree. So 56.30. If I subtract 56.30, 123.69, or you can say 123.70. So this angle is coming out to be 123.70. This angle is coming out to be 123.70 degree. But since it is measured in the clockwise direction, so answer would be negative of 123.70 degree. So here the angle is coming out to be minus 123.70 degree, and this you can write down as under root 13 e to the power j minus 123.70 degree. Well and good. So this was your Z2. This was your Z2. And this was your Z1. This was your Z1. What I can do now? So this I can represent as 5 e to the power j 53 degree divided by under root 13 e to the power minus j 123.70 degree. So 5 by under root 13, 5 by under root 13 e to the power j 53 degree. This negative sign goes upward, it will become positive. This much mathematics do you know? E to the power j theta 1 divided by e to the power j theta 2. If this goes upward, or forget about e to the power j theta, if simple e to the power theta, e to the power theta 2, if this goes upward, it would be negative. So e to the power theta 1 minus theta 2, right? And if they are in multiplication, e to the power theta 1, e to the power theta 2, so both will be added. Basically e to the power theta 2 goes upward, so it would become e to the power theta 1. If it goes upward, it would be negative. And since they are in multiplication, now these two will be added. So e to the power theta 1 minus theta 2. So similarly here, this is going upward. So what will happen? This will become positive. Downward it is negative. So if it goes upward, it will become positive. So plus 123.70 degree. So what we are getting? 5 by under root 13. So 53 plus 123.70 degree. plus 53. So 176.70. 176.70. So this is the answer of Z1 by Z2. Now can I open it up? Can I open it up? Can I open this thing? Yes, I can open this thing. So when you open this thing, your answer will be in this form, in this kind of form. Are you getting this point? When you open it up, when you open this up, your answer will come out to be in this kind of form. Although this will not be the answer. If I need the answer in A plus JB, so what I need to do, I just need to open it up. Okay. Now we will solve the problem Z1 into Z2 again. What I need to do, I need to solve Z1 into Z2 again. How will I solve it? What I am doing, I am solving C again, Z1 into Z2. What is my Z1? Z1 is 5 e to the power j 53 degree. 5 e to the power j 53 degree will be multiplied with under root 13 e to the power j 127.30 e to the power minus j 123.70. Now this is a real number, this is under root 13. So 5 will be multiplied with under root 13. So 5 under root 13 we are getting e to the power j 53 minus 123.70. How did we do it? E to the power j theta into e to the power minus j theta 2. E to the power j theta 1, e to the power j theta 2. Both will be added. But here there is a negative sign, so there would be a negative sign. So 53 minus 123.70, what we will be getting? 53. So 23 and then 30. Better do it with calculator. Why do we need to use our brain? In calculation, don't use your brain. Use the calculator, because in the examination you would be having the calculator. Although it was a very simple calculation, but I prefer not to do it with the help of my brain. I will use my calculator there. Okay. Minus 70.70. Use your brain in the concepts, not in the calculation. You are an engineer, right? So engineer would be more focused towards concept, not towards the calculation. So 70.70, 70.70 degree, or you can say 70.7 degree. So this is the answer we are getting. Previously, what is the answer we got? This answer we got. Now what answer we are getting? This answer we are getting. Can you make this answer in this form? Yes. What you need to do? You just need to open it up. So just open it up. 5 under root 13 remains there as it is. Cos of this angle, cos of minus 70.7 degree plus j sine of minus 70.7 degree. Okay. So 5 under root 13 it was. 5 under root 13 cos 70.77 degree. I just need to calculate cos of this. That is coming out to be 0.33 plus j sine 70.7. That is coming out to be minus 0.94. Minus 0.94. Now I need to multiply 5 under root 13. What is 5 under root 13? Can we solve it? Under root 13 into 5. So that is 18.02. 18.02. And this will be multiplied with 0.33 minus j 0.94. So 18.02 will be multiplied with 0.33. What we are getting? 5.94, which is nearly equals to 6 only. 5.94, although there are a lot of approximations, that's why we are getting 5.94 here. Nearly equals to 6 only. 5.94 minus 18.02 into 0.94. So nearly we are getting 16.94. J 16.94. So this is nearly equals to 6. What I can say? This is your nearly equals to 6. And this is 16.94 is nearly equals to 17. So yeah, we are getting the same answer. So in any way you can solve it. While doing your division and multiplication, I will use the polar form because it would be easier for me. if there are a lot of numbers, let's just say Z1 into Z2 into Z3 into Z4 into Z5. So if I go by this particular calculation, then I need to multiply first Z1 into Z2, then the number I am getting, then I will multiply with Z3, then the number I am getting, that I will multiply with Z4, then the number I am getting, that I will multiply with Z5. But if I write down in the polar form, what I will do? Z1 I can represent in this manner, Z2 I can represent in this manner, Z3, Z4, Z5. Then what I will do? These magnitudes will be multiplied. 5 into under root 13. Let's just say the next magnitude was 6, next magnitude was under root 12, next magnitude was under root 10. So all these magnitudes will be multiplied and the angle will be added. 53 degree, 123.70 degree. Here it could be 70 degree. Here it could be 90 degree. Here it could be some 53 degree. All these will be added, or it can be a negative sign. So all these angles will be added and directly I will get this form. And can I open this form? Yes. After opening this form, I will be getting this answer. Opening this particular form is very easy, right? Cos theta plus iota sin theta. So that I will open up and I will get this answer. So I will avoid this kind of calculation if the numbers are larger. Here only two numbers were there, Z1 into Z2. So it was easier. But if Z1 into Z2 into Z3 into Z4 into Z5 into Z6, so there I will use this particular analysis. I hope the basics of complex number is clear to you. This much you would have studied in your elementary classes. I wouldn't say elementary classes, but in higher secondary classes you would have studied it in 11th, 12th class. So this much basics is clear now. Next you need to see some basics of signal system. Next in this lecture series we are going to study about some basics of signal system, and after that you can start your network analysis. So this was the basics that I wanted to clear in the form of complex number, because a lot of students are confused in this angle. They usually mug up the formula. But there is no need to mug up the formula. I hope the angle concept is clear now. Once the concept of angle is clear, you can write down your complex number in the magnitude and angle form. These forms are known as polar form. This is known as rectangular form. This is known as rectangular form. But this is not important. The name is not important. You just need to represent the number. So this is how I can represent. This is how I can represent. Or this is also the way of representing it. Then you would know how to do the calculation. Z1 into Z2 angles are added. Z1 divided by Z2 angles will be subtracted. Right? And here like Z1 plus Z2, if I represent in polar form, I would not be able to do anything. What I mean to say, someone would say that, sir, I will do Z1 plus Z2. Z1 plus Z2. Using the polar form. What is the polar form? 5 e to the power j 53 degree plus under root 13 e to the power j 123.70. Now what will be the next step? Can you do anything? No. It is stuck here. Are you getting this point? Like when it was in calculation, when it was in multiplication, I could have done this calculation. When it was in division, I could have done this calculation here. But now it is in addition. I cannot do anything further. It is stuck here. So anyway, I will have to open it up. Same goes for subtraction as well. If these two numbers are not in multiplication or division, then you cannot do anything. You are stuck here. So that's why polar form is not useful if you are adding up two numbers or subtracting two numbers, or Z1 plus Z2 plus Z3 plus Z4 plus Z5. Even if I am doing these kind of calculation, there also I will not be using polar form. Because in polar form, if I write down, I will be stuck there. Nothing else I can do. Right? If I write down in the polar form, I cannot proceed further. I will be stuck there as it is. Are you getting this point? Right? So when we do the addition or subtraction, we will use this rectangular form. This is known as rectangular form. We will use this form. And when I am doing the multiplication or division, I will try to use the polar form. Is that clear to you? So you are not going to mug up that for addition rectangular, for division and multiplication polar. No, it should be clear to you. Then in addition, if I use the polar form, I am not going anywhere. So that's why I use the rectangular form. In multiplication, if I use the rectangular form, it will take some time. So better use the polar form. Okay. In division also you can use the rectangular form. Basically here I represented these number in the polar form only. How would you solve it using the rectangular form? You need to do the rationalization. So that process is not useful. Always we will solve with the polar form only. So just keep it here. Whatever that I have taught, just keep that much here only. Is that clear to you? All good? So some basics of signal system we are going to study. After that we will get into network analysis. All good? Thank you very much.